Okay, so first example, we've got a series and it looks to be geometric. Let's find the sum for 12 terms. So let's write down the stuff we need. U1 is 2. We need R. Well, R, of course, you can see there, look, R is 3 and N is equal to 12 because we're finding the sum of these 12 terms. And that would be S12, and that is equal to, and we'll just put it straight into that formula, right? So that formula, again, I'll put it over on the side here, excuse me, Sn is equal to U1, R to the N minus 1, all over R minus 1. So S12 is going to be 2 multiplied by 3 to the 12 minus 1, all over 2. Of course, the 2's cancel. 3 to the 12 minus 1, and that, if you put it on a calculator, is 531440. There we are. Okay, let's take a look at another example. Let's step it up a little bit now. So we've got to find a formula for the sum of n terms, and we've got a series given to us. Okay, so we're looking for a formula. This formula will have an n in it because we don't have what n is, right? So that'll be part of our formula. So let's just write down what we know. Well, u1 is equal to 9. R, well, I can just take one term divided by the prior term. You can quite easily see R is going to be negative a third. So let's pop these into the formula and see what happens. So Sn is going to be 9, 1 minus a third to the power of n. I will say I've used the alternative version of the formula here. Let me write that down. So I've used the version U1, 1 minus R to the n over 1 minus r, simply because I had a fractional r, and it will be a lot easier to calculate this way around. It won't matter either way, but I have that as a preference. So all that we're left to do is to kind of simplify this, right? So I think what we'll do, we'll pull that 9 out. The denominator there is 4 over 3, right? So we've got basically 9 times 3 over 4, right? Dividing by 4 over 3 is the same as timesing by 3 over 4. Multiplying 1 minus a third to the power of n. I think the smartest way of writing this is probably 27 over 4, 1 minus a third to the power of n, just like that. And we're pretty much there. Right, let's carry on. Another example. So in this one, we've got a geometric sequence again. We've got the first term given and the common ratio. Right, okay, so let's write that down. U1 is 5 and R is 2. The sum of the first n terms, so Sn, is 635. Can we use this to find out what n is? Well, same setup. Let's pop this all into one of our formulas. So we will pop it in to our formula. Sn equals u1 r to the n minus 1 all over r minus 1. So 635 is equal to 5 to the power of, 5 multiplied by 2 to the power of n minus 1, divided by 1, which is very handy. From here, I guess we could start to rearrange this. So if I divide 3 by 5, I will have 127 is 2 to the power of n minus 1. And then I have 128 is 2 to the power of n. You'd probably recognize that as a power of 2 already. So which power of 2 is it? It is 2 to the power of 7. So n is equal to 7.